Hi students, welcome to the third lecture, Failures of Classical Mechanics Part 2. Here I am discussing another phenomenon which could not be explained by classical mechanics, and it is the photoelectric effect. Photoelectric effect is the phenomenon of emission of electrons by the metals when they are exposed to light of suitable frequency, and the emitted electrons are called photoelectrons. Photoelectric effect was firstly discovered in 1887 by a German physicist, Heinrich Hertz. Further researches showed that it cannot be explained on the basis of classical theory of light, according to which energy of light depends on its intensity. If this view is correct, light of any frequency, if made sufficiently intense, can cause ejection of electrons. But this does not happen. In 1905, Albert Einstein explained photoelectric effect by applying the same Planck's quantum theory of radiation. According to this, light consists of bundles of energy called photons, energy of the photon being equal to h nu, where nu is the frequency of radiation. When a photon of frequency nu 0 strikes an electron in a metal, it imparts its entire energy h nu 0 to the electron. This energy enables the electron to break away from the metal or atom. Metal means it composed of metal atoms. It always have nucleus. And the energy of photon enables the electron to break away from the metal or metal atom by overcoming the attractive influence of the nucleus. The minimum frequency of the light to eject electron is called threshold frequency, and the corresponding minimum energy is the threshold energy. If the frequency of light is less than the threshold frequency, there will be no ejection of electrons. If frequency equal to the threshold frequency, the electron can easily detach from the metal, just detach from the metal, since the threshold frequency is equal to the binding energy of electron with the nucleus. Sorry, not threshold frequency, threshold energy is equal to the binding energy of electron with the nucleus. If the frequency greater than threshold frequency, the excess energy imparted to the electron to give it a certain velocity, and the electron will get a kinetic energy by which it emits. Thus, by quantum theory, Einstein explained the photoelectric equation as energy of photon absorbed by the atom h nu is used to detach the electron, which is also known as work function, and to the kinetic energy of electron. Here, the work function will be equal to the threshold energy, since it is same as the binding energy of electron with the metal atom. From this equation, we can write the kinetic energy of ejected electrode as h nu minus phi, which is h nu 0, where m is the mass of electron, v is the velocity of electron, h is the Planck's constant, nu is the frequency of incident radiation, and nu 0 is the threshold frequency, which is the minimum frequency needed to break the electron from the nucleus. Einstein, considered as the third founder of quantum theory, and for his laws of photoelectric effect, he won the 1921 Nobel Prize. Thus, the Planck's quantum theory can successfully explain the wave nature of radiation, and it has provided the illustration of different phenomena successfully. By this phenomena of photoelectric effect, I conclude my lecture. Thank you.